Alright, so welcome to a really rare weekend video of the JNCIE-SP. So let's just get started right away here. So we've got our lab from the last time, and we've got so I closed the window for the JNCIE-SP. I started a new series. You can check that out. It's on machine learning. It's just a public playlist like all my other stuff. So, but concurrently, I want to keep working towards this test because I think this is going to be the biggest immediate boost for me career-wise. I think I honestly have no idea. The machine learning thing could be better. But one thing I do think will be the case is if I know machine learning really well and I know networking really well, that's where I'll have the most opportunities, because kind of the biggest value in machine learning is its application. So if I can apply it to traffic monitoring, something like that, even develop like a new product I can sell, something like that, that's going to be really valuable. Okay, so in other words, it's worth it to spend time on both, is what I'm saying. Even if it sacrifices the quality of one or the other. Which I don't think it will, to be honest. Like, I haven't been doing weekend videos, and I've been using my weekend to study for that other course, so it kind of encouraged me to make a JNCIE-SP video, so I think it actually might even help my studying. And then I'm not going to study for that other course at all during the weekdays. I'll just study for the JNCIE-SP and do that course on the weekends. Alright, so okay, so here's the last video I did. Let's take a look at it closer. Yep, so it's video 2. So I think I have notes for video 3. I do, so here's my notes for video 3. And that's what I'm creating right now. So let me share my screen. Okay. So I've got my lab here. I believe we were just in the process of configuring just the most basic config necessary. So let's just take a look at the active config of all of these devices. In Cisco LAN it's called the running config, but in Juniper LAN it's called the active config. So let's look at the active config. Oops. Okay. Okay, well, I'm not sure what's going on there. Let's just take it one by one and look at it. Because we're having problems just opening them all together. Okay, so everything looks good here. Now we do have additional BGP neighbors that I don't think are going to be necessary. So I think I'm going to skip these because those are really simple, and we'll take a look at this one and see what kind of BGP neighbors we've got. Okay, so yep, we've only got one BGP neighbor. This is the .4, so we can get rid of the neighbors to .2 and .3, I believe. Alright, so now let's take a look at the other side and make sure that ISIS is configured properly. Okay, so we don't have any extra configuration on here, so we're going to need to begin the video today by adding ISIS. So this is going to be the equivalent of the R2 router. Okay, so we will need family ISO, and we will need family MPLS on those interfaces. Let's add that as the first thing. Oops, and I just randomly walked away from my computer for some reason. So let's keep focused and not do that. Let's stay at the computer and work on this. It might be a good indication that I do need a break. I have been working on machine learning a lot this morning. So I have had a lot of computer time this morning already, so I might need to take a walk outside or something like that. That might be a good indicator of that. But let's just finish this router, take a pause, take a walk out back, and then come back to it. Okay, so oh, it looks like I don't even have the loopback address configured at all, which is interesting because I thought I had those configured throughout the topology, but apparently I do not. Let me remind myself. Okay, so this is .4, so we're going to have .5, .6, and .7. Okay, so now I'll commit all these. Kind of did that a bit out of order. I just didn't want to have to sit and I just didn't want to commit them yet until I had all the routers ready to go. So I think I will need to make some new changes. I forgot to add the family ISO and family MPLS to the physical interfaces on the other routers. So let's just print out this one, because this one, as far as interface configuration is concerned, is good to go. So let's compare that to these other ones. Okay, so we're going to need to add that here. Okay, so I think we're good to go as far as interface configuration is concerned. So let's move on to the next step, which is going to be the rest of the config here. And this might actually be a good place to take a break. So I'm going to do that. I'm going to take a quick walk out back, and I'll be back and hopefully much better able to focus on this. Alright, so I'm back. I thought I could do 2 laps, I could only do 1, it turned out. But yeah, it's pretty hot out there, but let's continue on. So, it looks like I'm going to need family ISO enabled on the loopback interface. Now I'm really surprised they're not having an address. But we'll see as we go on if that's going to be a problem or not. Alright, so next part is going to be the router ID and the autonomous system. And we'll be doing that for all the routers as well. Let's just get the common config in a Notepad++. Okay, so this is not going to be common config, so let's just include autonomous system. 65534. Set protocols. Mpls interface all protocols, Mpls interface xp0.0 disable. Set. Okay, and I forgot the Ebgp configuration on the other one. I think that's okay for now. I'll set it up on this side, but it's not going to go into establish because I don't have it set up on the other side. Okay, so this is an Ebgp, so the peer is going to be with this interface here, ETH4, which comes out to GE002 on P1. So let's take a look at what the address is on that, if I may. Alright, so 10.0.5.1. There we go. Okay, now it's time for ISIS, and we can disable level 1. I'm going to need to do that so those CSPF calculations aren't, so we don't get multiple CSPF calculations for this ISIS area. Again, I forget what ports we're using, so let's take a look. Okay, we're using ports 1 and 2. Okay, so we're using ports 1 and 2 for this is the ISIS configuration. So yep, and we'll skip all this stuff for now. Try adding it if it doesn't work because we don't have a ISO address, so that might be necessary, but for now we'll just skip it. So this is interesting. It looks like they've got Ospf and ISAS. Okay, but Ospf is only enabled on the external interface, so ETH2. Okay, so we'll start with this stripped down basic config on R2, and then we'll just add the kind of easier config on the transit router, and then we'll work on the last one, and then we'll come back and add the extra sprinkles. Okay, so hopefully we got no issues with that commit. I have a feeling we might have issues. Oh, usually one takes this long though. Yep, so we're good. Let's move on to the internal router. So we've got no instructions for this one, but I think just based on what I've learned so far, I can get it to work. So obviously we're going to need interface configuration, but I think we've finished that already. Yep, so the interface configuration looks good to go. We're also going to need protocol configuration. We won't need any BGP configuration, but we will need Mpls, and we will need ISAS. We won't need any Ospf in this case. Now we're also going to need RSVP as far as I understood, but I don't see it enabled on the other router, which is a little bit odd to me, but let's just start with this stripped down config here. Okay, so I configured router 1 and router port 2. It's actually going to be 0 and 1. So I made a mistake here. Let's undo that mistake. So we'll do configure private, just roll back everything. So we'll do a rollback 1 commit, and then we'll just repaste what is meant to be on there. Okay, so we've got what's meant to be on there ready to go now. So now we can move on to the other one. We are missing protocols RSVP, but that was not included. Oh, it was. So did I skip it from here? What the? What did I configure? Alright, so I'm not sure what I did. I clearly did not do what I intended to do. So let's try to get back to where we once belonged, as Paul McCartney would say. Okay, so and let's carefully double check which router we're on. We're on P2. Okay, so that's the one we want to be on. So let's add the configuration that we actually wanted on there. Oh, and let's add RSVP, because that was just something I missed. It was listed in the directions, but I did not see them there. Oops, so it's going to be then accept. Alright, so hopefully this commits and hopefully it shows up. I think, oh, you know what, maybe because I rolled it back on here by accident. I guess I'm not sure what happened. Let's do a show configuration, pipe display set, pipe no more. Okay, so we're good to go on this one. Let's move on to the next one. Okay, and this one has, okay, this one's good to go. So, except for it's missing protocols RSVP, so let's add that. All right, so we've got this one ready to go. Let's go on to the next one. All right. So this does have IGP, and that's interesting because there's no other router that has IGP on it, except for this one here, but I don't think it's neighbors with that other one. And this one has it too. So I think they're missing some Bgp configuration from one of these routers. I think there's an error in this. But we can submit a downvote once we're more certain as to what that error is. So for now, I think I'm going to leave the BGP configuration off. ISIS I'm going to add, but I need to figure out which port, so port 0. Okay, and then we've got it disabled at this level, so we don't need it down there. Oops, so this is interesting as well. So they've got ISIS and they've got Ospf configured for this one as well. That looks like it's a mistake. You're only going to need one or the other for this router. Oops, and it looks like they're renaming the policy to accept all. Okay, and then they're adding it into OSP to MPLS. So we can leave this out for now. Yeah, it looks like the instructions are leaving a lot to be desired so far, but we'll lend Juniper a hand and put in a good downvote once I have figured this out better. Okay, so we've got everything good to go, I think. So, oh, I just had an interesting thought, just pop into my head randomly out of nowhere. It is a thought that I have actually thought about before, but just the fact that I'm learning machine learning, I just want to have this written down somewhere. So I'm just going to write so I'm going to write down here. So real world machine learning application idea number one. Real world machine learning idea number one, monitor traffic statistics on a network and train an AI model to recognize when the traffic changes well, you know what? I don't think that's actually I don't think that the thought that just popped into my head while I'm tired and a little bit stressed from working on the machine learning thing all yesterday and stuff. I don't think it's really a valid thought. So let's configure on. You can see my mind's kind of a mess right now, but I think I can get through this. So yep, and I've already put the configuration on there. So let's start with some basic things. Let's start by looking at the topology some more. Yep, so now mine's going to be a little bit different, but this PE2 is basically the same as R3, so it's just going to belong to ISIS. So let's look at the ISIS neighbors, or adjacencies as they're called. Okay, so we don't have any. Let's look at the Ospf. Okay, we don't have any of those either. Now this is only meant to be in the ISIS. It's only meant to have ISIS, so I'm going to delete the Ospf configuration just because it's confusing. Okay, and then I'm going to go over to the router that it could not form an adjacency to here and see what I can do. Okay, so we've got no Ospf on this. That's good. We do have everything looking good on here. Let's put them side by side. So I'm going to do detach. I'm going to put this side by side. And let's do a show configuration protocols. SIS, pipe, display, set relative. Okay, so let's do a okay, so let's make sure that it's wired up correctly, and it is. So let's make sure it can ping across the wire. Oh, so it looks like it can't ping across the wire, so that's the first thing we're going to need to troubleshoot. Oh, actually it looks like it can, so that's good. But it can't form an adjacency. And the reason it can't, I think, is because it's missing that NET. So let's open a new tab here, and let's do Juniper downvote, and we'll say number 1, ISIS NET addresses not shown. Now they did give some kind of special config. So let's try adding that, because that might be the solution to the problem. So the special config they added did have a ISIS NET. Oh, but I don't see one here. I do see one here, but that's yeah, I don't understand what they're doing there. So I think I'm going to include that in my downvote. And it's just going to be not configured on each loopback. Oh my god, I'm tired. Oh, I might need to take another break. I'm going to take another break. I'll be back. Hopefully I'm feeling better. I can probably even do some caffeine today. I got up a bit early. Somebody called me at like 4 a.m. Yeah, so hopefully I'll be able to make that sleep up tonight. But for now, I'm going to just take a break and then come back. Okay, so I'm feeling a lot better after that break, so let's continue on with what we were doing before. I think what I was doing before was pretty difficult, but let's see if we can make more progress. We might have to abandon this and move on, just for the sake of making progress. But we've got a number of things that I intend to downvote this documentation on. The first thing is that the ISIS NET addresses are not shown to be configured on each loopback interface, and I think that is absolutely necessary. So let's add those for the 3 routers that are going to be using ISIS for their IGP. So we'll do show int lo0.0 pipe display set relative, and then we'll do edit int lo0.0, and we'll do set family ISO address, and now NET address is going to start with 49, then it's going to have the area, and then you can have an extended NET or a regular NET. So you're not quite limited by how many characters. We're gonna do a extended NET, and we're gonna do 1 like this. So we're just gonna have it be the address that is on the loopback interface, and we're gonna pad it with zeros in the beginning. Like that. And so this is going to be a valid NET, but it's going to be an extended NET. Network entity title. Perfect. So let's go and add that to the other routers, and we'll start with there. We'll start with that, and hopefully we'll see those adjacencies come up. Okay, so we've got a valid NET here now, so we'll see an adjacency, but before I check, I'll just finish what I'm doing by configuring an NET on P2. I don't need to see the active configuration, I just need to see the candidate configuration for loopback interface. Okay, so now we'll see adjacencies, so let's wait until this commits and then check it here, and then well, actually, instead of doing that, let's just go right here and check it here, because then we'll be able to see both at once. Otherwise, we'll just be able to check one adjacency. We get more bang for our buck if we're here, and we can see, yep, we've got, our adjacencies are up now that we have a NET, because we've got this, yeah, we've got a MAC address now, but I was going to say this is tied to the NET, but it looks like it's not. But anyway, we saw, that was the only change I made. So sure enough, it does require that NET on the loopback interface in order to come up, which is something I knew, and we're going to download this documentation for at least that. But let's see what else we're going to need. One thing that is definitely missing right now is the Ebgp connection, so let's add that. Okay, so it's going to be 0. Oops, and it looks like we've got the wrong. Oh no, it is correct. It is correct. So, oops, no, we do have the wrong neighbor here. It's going to be 5.2 is the neighbor. So let's fix that. Okay, and then let's set it to 5.2. Perfect. Okay, so I think we're good to go. Let's ping 5.2 just to be extra sure. And discard, we're not going to discard the committed changes. We're going to commit and quit. And we're going to ping 5.2. Okay, let's make sure that the BGP neighborship, okay, it's not going to be up yet because we haven't configured this other side, so let's do that. Oh, it looks like we actually did configure the other side, so it could be up. It looks like it was in open sent next, so it went back to active though, so there is going to be a problem of some kind. It looks like I've got the wrong peer AS. I instead put my local AS by accident. And for that matter, it looks like I configured the wrong local AS as well. Okay, so hopefully it will, sometimes it takes a little bit of time for it to come up. So let's just watch it every second and see, yep, now we've got open sent, so hopefully it will go open confirm and establish. Once it's in open confirm, it's definitely going to go into establish, and as I've mentioned many times before, it's actually rare to see it in open confirm anyway. So okay, now that we've got that working, let's take a closer look at the active configuration. Okay, so we see for G002, yeah, we've got some extra configuration on there that I don't think will be necessary. One other thing I see is we've got ISIS enabled on this. That's not going to be necessary, so let's get rid of that. Okay, now let's look at PE2. Okay, so PE2 also has Ospf, but that's not going to be necessary. This is just ISIS, so let's get rid of that. And then the downvote, only ISIS or Ospf is required on the intra AS routers, not both. Yeah, I'm okay with that word, required. I thought about changing it to necessary, but I think required is okay. All right, so let's go back to the lab and let's look at the verification steps. Okay, so the first thing we're going to do is show Bgp Summary, and we're going to do that on R0. So I'm going to take a screenshot of the topology so it's easily accessible. Okay, so here's R0, so it's going to be an iBgp connection. Right. Okay, and then the peer is going to be 141. Okay, so yep, it's going to be an iBgp connection to this here. That's what I thought. So I'm gonna configure that because I don't have that configured at all. So I'll configure an iBgp connection between PE1 and P1, and that'll be my version of this verification command. So P1 is going to have both eBgp and iBgp configuration on it. And let's detach these and put them side by side so it's easier to work. Okay, so show configuration, pipe display set, pipe no more. So yep, we've already got some BGP on there, but let's see if it's accurate. So we've also got BGP on here as well. Neighborship. Looks like it's pointing to the right neighbor. Yep, so it looks like BGP is actually configured correctly. Oh, and it's an established as well. I thought I saw it was an active over here. Nope, it's an established. Okay, so I can consider this step done actually. Now they want to do it on R1 as well. But this is R1, so we already did it there. Yep, and we can see we've got the external and our internal connections. So everything's looking good. We don't have iBgp set up on this side yet. So I'm going to do that, but first I'm going to take a quick break. I'll be right back. Alright, so I'm back. So let's pin up the iBgp connection in the ISIS area. Okay, so we've got everything looking good. Commit that and quit. Okay, and we'll do a pipe refresh 1. Okay, we're in connect state, active. Oh, so we went from connect and we went back to active. So there's some sort of issue. Let's try to figure out what that issue is. We'll start by pinging. Okay, so pinging is totally fine. Let's take a look at the configuration some more. Okay, so I think what happened is it went back to active because of that race condition. So it is not necessarily always an indicator that it's not going to go into established if it goes from active back from connect back to active, because it could be backing off and allowing the other side to initiate if you don't use that as passive knobs. Okay, but we're good to go now, so let's continue with the verification steps. So the next verification step is going to be show Mpls Lsp on this one. And we won't have an LSP, so we'll go back and we'll create it after we verify that we don't have one. So no LSPs, let's go create the LSP. Now, it's not going to be R3 in our topology. It's going to be PE2. Okay, so we're restricting the bandwidth that's available down to 40 meg. Okay, and then the last thing, so I almost forgot the most important command. It's going to be to enable cross credibility for CSPF, otherwise those calculations will fail because it's only considering the Ospf, SPF calculations and not the calculations from the other region that were provided by ISIS. So let's enable that. Perfect, okay. So let's go ahead and do this traffic engineering export policy as well. Okay, so now we've got to go down to accept all and configure that. Okay, so we're good to go. I don't think there's any more LSPs besides that one. And LSPs are unidirectional. You will need additional LSPs if you want to have an exchange of traffic, but just to learn about it, you only need one. Okay, so the next step is going to be show Mpls Lsp. Okay, so now we've got one. We've got our from isn't filled out, and we don't have an active. And we've also, oh, so it's in state down is why we're having problems here. Okay, and I think that's because we didn't do a lot of extra, that kind of sprinkles config. We didn't sprinkle all throughout the network. So let's add the sprinkles right now to the cupcake. Yep, so we'll need something to Bgp. Okay, so I think that was the only missing command from this one so far. So let's see if it changes the output. I have a feeling it will not, because I still haven't, I think cross compatibility for MPLS is the key missing thing. Yeah, so this won't go up until, at the very least, I have cross compatibility enabled. I wanted to say on all of the routers, but I don't see it added to all of them. But this might be something to include in the downvote vote, that cross-compatibility must be enabled on all routers. Or cross-credibility. I don't know what I said. Compatibility. Okay, so let's skip over to this one. We'll miss these for now, but we'll configure this one. Okay, so we're going to need this. Okay, and then we'll need this. We'll need the policy that defines it, of course. All right, and then we'll need this. Okay, we won't need any ISA, this is just for Ospf. Okay, and then I'm going to skip those traffic engineering passive for now. Okay, and I'm not sure if I added this, but there's no harm in just adding it again. Okay, and I don't see where this is being called. Let's get a better look by using the find. Okay, so it's not being called anywhere, so it doesn't need to be defined. It looks like I defined it, but that's okay. We'll just leave it defined. Commit and quit. Okay, so yeah, I think everything's good to go. Let's configure these other two routers. Okay, so on to the last router, and then we'll need to probably go back and add some extra configuration to the transit routers, but for now let's just focus on these. And I'm really surprised that cross-compatibility or cross-credibility command is not enabled. Okay, so let's see what our LSP looks like now. Okay, it's still down. Let's try to enable the cross-compatibility or cross-credibility command on all of the other routers. So now it's going to be under RSVP, I believe. Oh no, it is going to be. Oh, I see. So it belongs only to the label switch path. Okay, so why is the label switch path down? Okay, so let's start by pinging. See if we can ping end to end. Ah, so we've got no route to host. So we got to learn that route through BGP somehow. Let's take a look at what P2 is exporting for BGP. So show routes, advertising protocol, BGP, and then I forget what the neighbor was. I think it was, so show BGP summary. Oh, this is interesting. So it looks like my connections went down. So right now, of course, I'm not going to be advertising anything with those connections down. I think that had to do with my changes that I made. So let's roll those back. Okay, so now show configuration, pipe display set, pipe no more. Okay, so we've got more changes on here that might be affecting the status of that BGP neighborship, so we're going to roll back those. Take a look at what I'm rolling back beforehand. Okay. Alright, and I'll be back in just a minute. I need to, oh, no, it looks like it's in open confirm now. Perfect. Okay, so the other one still had those changes on it, so let's roll it back on this as well, and on PE1, and see if we can get this to go active. So we know very clearly there was something wrong with that other change. And one thing I can do is show pipe, compare pipe, save, and say bad changes.save. So I can go back and easily look at my bad changes at any time. That's going to be really helpful during the exam. So now I can do a file show bad changes.save, and I can see exactly what I pulled off because it was causing issues, and I can go back and figure out why. Okay, so this should go to active again now that we don't have those bad changes anymore. And let's pull them off of PE1 as well. Okay, so we're in active again. Let's see if we can get a route now. Oh, so we're still not getting a route, but of course we are going to need those adjacencies, so I can't have that configuration on there. But let's see what we are advertising. Okay, so we're not advertising anything. So let's take a look at our BGP configuration. Yep, so we see we do have an export policy. So let's see what we're exporting. So we're doing from family traffic engineering and then accept. That's not going to be a good enough policy. We're going to need to fix that so that we're matching an actual route. So instead of that, let's do edit policy options, policy statements, NLRI to BGP, term 1. We'll say set from route filter, and we'll do 10.255.0.7, and then we'll do exact. Okay, and now we're going to have a route being advertised. Perfect, and then we'll have a route in the table now. It will be a BGP route. Perfect, so now let's see if that Mpls Lsp is up. Still down. Let's see if we can ping that now. Okay, it looks like we can't ping it. I'm going to take a quick break. I'll probably be back soon, hopefully. Alright, so welcome back. I've taken plenty of breaks. Let's keep working on this. The video is starting to get a bit long. It's been like an hour. So I'm going to try to wrap this up. Basically, my goal is just to get all these verification steps working. So the first ones I already do have working. They are just making sure all the BGP neighborships are up, which they are. But the second one here, I have it showing up, but I have the LSP down. So let's try to figure out how to get that LSP to come up. Oops, and I have an automatic reboot cron job on this at 11:45 every day. So I recently had a license change where I can only have 8 vCPUs instead of 16, so it takes a little bit longer to load. Usually it's up and ready to go by 12, but before I had that license expire, it only took 6 minutes, and it looks like it's taking a bit longer than that right now. Okay, so I think what I might end up doing is just ignoring this lab and just trying to get this LSP to come up. It's turning out to be too difficult. like if it is legitimately this difficult on the exam where I've got to create these policies for traffic engineering and all that, yeah, I don't know how they would expect anyone to pass it. Okay, so this is going to take a while to come back. I think I'm going to end the video here since it's an hour long already. And then in the next video, I will be dealing with this. So stay tuned, and I'll see you in the next one.